Good afternoon, everyone. I'm glad to be here. My name is Chen Qing Li, aka Li. I'm the founder of Creot. So, firstly, please allow me to introduce my company. So, Creot is a pioneering transdisciplinary design, innovation, and development company. We use design, innovation, technology, and intelligent automation to create changes in the AEC industries. Our integrated multidisciplinary team of architects, engineers, designers, project managers, builders work closely together to ensure a seamless delivery of architectural design and development. So the company, under the Creot brand, it consists of four companies. Creot Architecture, award-winning architectural design practice. We also have our own construction company. So, and then it's supported by the Creot Integrated Smart Solutions, which was launched last year as a technology company, a technology startup. We develop and program our own intelligent automation tools for DFMA on the 3D Experience platform. And we're also in the process launching a new company, actually, Creot Homes, using Creot Integrated Smart Solution automation tools, as well as the building system we have developed, which is called Creot Aeronautics Building Systems, CABS. So firstly, I like to share a personal story, and it was my very first project named Creot Pavilion, which was built during the London Olympic Games in summer 2012. So companies such as Apple, it has got the same access, talent, technology, marketing conditions, and consumers as other competitors. So how does it continue to lead innovation? As a typical architecture student back in 2010, I didn't have the recipe of success, but I wanted to design and build a pavilion for my final year project. When I showed some rough sketches of my ideas to my colleagues, they said this is impossible. The challenge was not only to solve the design issues, but also to raise the money. So the question was how to raise the finance in the middle recession, and also such a complex project. How much would it cost? So who would build it, and where to exhibit it? I couldn't answer all the questions, but I believed. So I started approaching companies such as, companies as a salesperson for sponsorship. After thousands of attempts, rejections, and failures, I actually sent out around 5,000 sponsorship sales pitches via posts, emails, phone calls, and meetings, and have spent around £2,000 on envelopes and stamps. So luckily, I have convinced a range of people and companies to believe in my pavilion design and the workflow, so which I will discuss in a few minutes. And they kindly provided me their products and the services and made this project happen. So, for example, the exhibition space was sponsored by Lendlease and Quintain, the landowner and developer, and engineering services from Ramble and Evolute, and Eco Timber was from Cabinet, Tencel from Tencel Fabric, and the labor from volunteers. So this a project, is a pavilion and a dynamic exhibition space, so you can push them around, creating different types of exhibition space during the day. So at night you can push them together. It glows dark like a Chinese lantern, but it also secures itself. And for this project, it's not just a design or DFMA, it's actually a workflow I like to talk about. So the process was forward thinking, from design, engineering, manufacturing to construction. It was paperless. So the only paperwork we had was the assembly diagrams, which was printed on the A3 paper. So this is the steel base, we call it steel plinth, and the steel hoops. So I did a detailed building information and manufacturing modeling. I call it BIM, B-I-M-M. So I issued this 3D model directly to the steel fabricator in Nottingham. A couple of weeks later, the steel fabricator came back to me with a set of shop drawings. And I'm just very kind of curious, actually. If you have the detailed fabrication modeling, why do you need drawings? It's almost like one step forward and two steps back, just like the general BIM model we do on Revit or ArchiCAD or the BIM softwares. We do this kind of intelligent 3D models, and then we issue the 2D drawing packages for construction purposes, which is rather strange. So if you look at this image, the brackets in different shapes and angles, and the question is, how do you describe them on 2D drawings? And the next one I'd like to share is this kind of this was a one-to-one scale mock-up and the engineering testing at Cambridge University. So this pavilion has got reciprocal connection details. So the option A we did, we didn't have a notch. As you can see, there's a notch here. This is option 2, and unfortunately the engineering test wasn't ideal. But option B, we have these notches, which is much stronger. And the problem was, when introducing notches, that means there'll be more fabrication process, which will cost a bit more money, which is it's a bit problematic. I had a very tight budget for it, but I've managed to convince the fabricator to do this the notches for free of charge. Another thing I like to talk about is this, you can see this M6 bolt with dowel connector, and also there's a washers as well. And the structural engineer wanted stainless steel bolts, and which is quite expensive. I had to order large quantity. I think it's 10,000 pieces minimum. And but if we use M6 bolts in mild steel with zinc coated, it's so much cheaper. It's about 12 pence per set instead of £15 in stainless steel per set. And this was the manufacturing process. So each pavilion consists of 997 unique pieces, and the tolerance was minus plus 0.02 millimeter. So if each component was 1 millimeter bigger, 997 pieces later will be 1 meter off. So this is very important, the accuracy. So in terms of sustainability, this is Eco Timber by Cabinet, and also we try to minimize the waste. So what we did on the 3D model was we created a bounding box for each component. So then it gives us the maximum length of each component. And then we add a 10 millimeter extra for each timber plank. So when you're cutting them, it's actually minimum waste. You can see very small pieces of timber, and then the most is just sawdust. And this is cutting the notches and chamfers, everything, and the one using robotic arm. And another process we did was we converted this building information manufacturing modeling into G-code, so the robots understands it. So you just carried out the cutting, drilling, etc. As you can see, this component, when you cut it, it's a 3-dimensional angle. It just couldn't be made by hand. That's why we had to use a robotic arm. And so this is, as you can see, the beauty of this workflow is the DFMA is it doesn't require any skilled workers. As you can see, nearly 50%. All of us, we didn't have any construction experience, and as you can see, nearly half of the construction team members were female. And some more pictures of interior shots. So the cost is very important actually. The evaluation engineering was £1 million plus contingency, and if you look at the O2 Arena behind us, the original budget for that project, I believe, was £380 million, and the final cost was over £1 billion, nearly three times more than the original budget. So my little pavilion was £1 million plus contingency, which means it could be 2.2 or 3.5. It's just high risk projects, and considering the geometry, double curvature, etc. But I have managed to deliver this pavilion around £240,000. So it's a quarter of the estimated budget, which is quite interesting. So I was the developer, financier, designer, salesman, sponsorship liaison, human resources, project manager, principal contractor, builder, and the end user. Yes, I pretty much did everything, but I wasn't Superman. It was the workflow which allowed me to control the entire process, from design, engineering to construction, and then more importantly, the quality of the buildings or the quality of the end products. So I did prove the concept of the benefits of DFMA, and which was really, really important. And so coming back to the traditional meaning of architecton, it was in Greek in the mid-16th century. Architects were not only the master of spatial effect, they were also closely involved in the construction process. Unfortunately, architects nowadays, this role has been shifted away a lot, and we're no longer leading the construction process or inventing a new construction technique, only just a part of the design team and the drifting. So that's the kind of moment I decided to switch to CATIA in summer 2020, and then we started doing a range of as a turnkey design build contractor. So this is the project we did. This is in Surrey, and it's a very open-minded clients, and they like to use this new construction technique, and giving me this opportunity. And the project is in on the Greenbelt. They hired 2 architects before me from, they won the grand designs, but unfortunately they didn't manage to get the planning permission. The planning rules in the UK is quite strict on the Greenbelt and in the conservation areas. Plus, there's so many protected trees around, and yes, we did get planning permission last March, and we started developing. We switched on to CATIA, and this was the mock-up we did on the 3D Experience platform. It's a walk system, 3D mock-up with the 100% details. There's no level details. I don't really understand why we have level details in the first place. So this was the steel metal design roll, so you can unfold them, and you can also set the K factors, the manufacturing, the bend parts. 2mm aluminium was the K factor, and also convert this into a parametric 3D. So it allows me to instantiate this component, panelized, and change the size of the panels automatically. And then following that, we did. I did realize, there's a challenge is is huge because the CATIA is a very difficult tool to learn. So I formed this company called the Creole Integrated Smart Solutions, and we have developed and are still in the process developing DFMA intelligent automation tools. So we're aiming to save up to 80% of time on design, detail, engineering, and the manufacturing process. So for the business and the finance point, from the business and finance point of view, is CATIA, or 3D experience is high risk. Number one is the software. It's very, very expensive. And number two, there are very, very few people in the AEC industries know how to use it. So I came up with this idea. We should develop our Creole's own tools, which are easy to use, and getting the building information modeling, building information manufacturing modeling done with just a few simple clicks. This is this is where I come from. This is the demonstration on one of the Creole tools. It literally takes a few minutes to generate this, the details. And this is the another example. That's just the facade. This building took about 5 to 7 minutes to generate 100% detail with a manufacturing BOM list. As you can see, all the details, parts, and components. Here we have the panels, cladding panels in different sizes. Cladding rails and brackets, bolts and nuts, all here. And we also we programmed the tool so it generates the the shop drawings automatically. So it does a list as well. So it tells you there are 35 types of panels, and each type consists of the numbers of type number 1, quantity 11. So automatically generated shop drawings, the panels, the size, dimensions. So I just issued this drawing package to a steel fabricator directly. So as a developer and turnkey design and build contractor, I'm more interested in the cost, So the Creole tool could give me an accurate cost without a quantity surveyor. And another question is, we did all this intelligent automation, which is great. What then? We still had to rely on people, on site to assemble these buildings. So how to do that? Because the builders, they have very simple mind. They just want to know what needs to be done. They don't really get all this, technology side. So in that case, another solution, we create. We also in the process developing a construction sequencing management tool. So it just informs builder what's the next component needs to be assembled on site. So it's a very very simple and straightforward. Obviously, this tool is still on the early stage, and it will be ready by the end of June, I think. Yeah. So our aim is we aim to save up to 50% of time on the construction speed, and also we're doing a range of in the process doing developing new social housing projects. So all these savings on the design, engineering, fabrication to the construction, Creole will contribute 40% of cost saving to the social housing developments. So it means that we are in a very powerful position to design and deliver high quality and sustainable homes. So Henry Ford once said, if I'd asked people what they wanted, they'd have asked for faster horses. Does this logic hold up today? So my question for everyone in the AEC industries are, what solutions do we want exactly? And I do hope the answers are something beyond the bin. Thank you very much indeed.